Hello everyone. Today let's solve the problem card back. Right. So this was asked on the educational code forces round 64. This was rated for this one division 2. So let's see what the question states here. You can just go through the question. It's easier to understand. I'll just summarize the question so that it will be easier for us to solve the problem. Right. So now let's see what the question states. So we have n cards, right? So we have n cards with the values a1 to an, right? So these are the values, right? So a1 to an, right? So we have n cards with the values a1 to an. So we have to draw a random permutation, meaning we have to pick cards without replacement. Just remember this, we have to pick the cards but without replacement, right? So this is one of the criteria. So we have n cards with the values a1 to n. Draw a random permutation, then the game stop at the first adjacent pair that is not strictly increasing, right? So the game stops when the game stops at the first adjacent pair, right? So that is not strictly increasing. If they are equal, then it's a win, right? If they are equal, then it's a win. If the second is smaller, see, if the second is smaller, then it's a lose, right? So then it's a lose, right? So this is fine. We have what we need to do then. We have to compute the probability of winning, right? So we have to, what we need to do here, we need to compute probability of winning, right? So this is basically a kind of problem, this one number theory problem, right? So this is fine. We have to compute the probability of winning, right? So if I'll just write win here, we have to compute the probability of winning basically. Output, we have to output this one as p into q to the power of -1 mod this one mod value they have given here. See here, p into q to the power of -1 mod this one, right? So we have to compute the output, this one. We have to output it as p into q to the power of -1 mod this one mod value they have given 9982444353. This is fine. Now this is the mod value. This is fine. Now I hope the question part is completely clear. Let me read this one again. So we have n cards with the values a1 to n. We have to draw a random permutation. The game stops at the first adjacent pair that is not strictly increasing, right? So this is fine. If they are equal, then it is said to be 1. If the second is the smaller, then it is said to be this one lose. Then we are losing. So we have to compute the probability of winning, and we have to output it as p into q to the power of -1 mod the mod value they have given here, this one, right? So this is fine. I hope the question part is completely clear. Easy one, right? So now let's get into the this output part here, input output part. So n we have been given 5. The first example I have considering here. So n we have been given 5 here. Just give me a second, 1 second. 1 second. This is not working. Yeah, n we have been given 5 here, and array we have been given 1 1 4 2 3, right? So this one, the output that we need to get are is this one after applying the this one mod value, right? So we have to get the output this one. Same goes with example 2, same goes with example 3 as well. Yeah, we have only 3 examples, I believe. No, 4. Same goes with example 4 as well, right? So 2 3 4. So this is about the question and the input output part, right? So now we are familiar with the question and the input output part. So we have the understanding of it. Let's do one thing. Let's quickly discuss the approach and the complexities. Then let's write the code, right? As usual, let's discuss the this one approach first. So here I have considered the same first example that they have given in the question. So n we have been given 5, and this is nothing but array, right? So array 1 1 4 2 3 we have. So after applying the mod and performing this thing, what do we call? We are done with the approach. We have to get the output this one, right? So modular value they have given as well. So for this we'll be going with a dynamic programming. Just remember this one. We'll be going with a DP, right? So DP approach basically, right? So let's go with the, or let's move on with the step-by-step explanation. So let's discuss the idea first. So what we'll be doing first here, so we will treat the random process as the random permutation, right? So we'll be going with, let dp of I be the probability that after I picks the last pick value is v, right? After I picks the last pick value is v. and all the previous picks was strictly increasing. They have strictly this one, they have given this one in the question as well, right? So they have said that the game stops at the first adjacent pair that is not strictly increasing, right? So what's the idea here? We are treating the random process as the random permutation, right? So let dp of iv be the probability that after I picks the last pick value is p and all the previous picks for strictly increasing. That we have to maintain. This is fine. Now from dp of I minus 1, what we'll be doing, we have to add to the answer the probability that the next pick is equivalent to the last value v, right? Let's see the same thing further within the code actually. Now let's discuss, let's move on with the further things. We have to extend the strictly increasing prefix by picking a larger value, that is u greater than v. Just keep this in mind, this is important as well, right? So let's move on with the further steps. So let's move on with the first example that they have given here, right? So first example in the sense, this one I have considered, right? So n equals 5 we have, and array we have 1 1 4 2 3. This is fine. Now count of 1 is 2, right? So count of 1 is 2, count of 2 is 1, count of 3 is also 1, and count of 4 is also this one. We know this, right? So this is fine. Now let's go with the probability. So let's go with the dp of 1. Probability of the first pick is 1 equals this one. We have count of 1 equals 2, right? So and we have 5 array, this one, and we have been given 5. So we'll be going with 1 by 5 and all others. So count of 2, count of 3, and count of 4 is 1 basically, right? So this one is 2 equals 1 by 5, 3 equals 1 by 5, and 4 is also 1 by 5. This is fine. To this one, 1 equals 2 by 5 because count of 1 is 2 here, right? So this is fine. 5 is nothing but n, we have been given 5, 1 1 4 2 3 number of elements, right? So this one here 5. So winning at the step 2, meaning only possible, it is winning is only possible when previous value was 1, right? So let's go with the contribution this one, 2 by 5 count of 1, this is nothing but the 2 by 5 is count of 1 into count of 1 minus 1, nothing but here how can we write this one, uh, we are going with the count of 1. Count of 1 is nothing but here this one, what do we call 2, right? So this one will be going with a 1 by 4 basically. 2 by 5 into 1 by 4 by remaining basically. Remaining is nothing but the 4, right? So 2 by 5 into, or this one count of 1 is 2, 2 minus 1 is 1, right? So 2 by 5 into 1, the remaining is nothing but 1 by 4 here in this case, right? So 2 by 5 into 1 by 4, 2 by 4 into 1 by 4, this one 2 ones are 2 2s are 4 here, 2 1 equals 4, right? So 1 into 1 is nothing but 1, 5 into 2 is nothing but 10, right? So this will be 1 by 10 basically. This is fine. 1 by 10. Now no other equal pair possibilities occur later, right? So total win probability will get here as 1 by 10 itself. So we know how we got 1 by 10. So this, for this we'll be applying the modulo value. They have given this one, right? So we'll be applying the modulo value. When we apply the modulo value, we get the value this one, 299473306. So this we will be returning as the output basically. So this we will return as output. So the output that we got here is 299473306. See here the final answer, 299473306, which is equivalent to the output that they have mentioned for the output 1 within the example 1, right? So within the question basically, within the example 1 within the question. This is fine. Now as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So what will be the time complexity here? So the time complexity would be big of n square. So why it is n square? So we will be going with the 2 nested loops over up to n values and n steps, right? So this is dominated by for 1 equals I to n, and for this one j equals 1 to n, right? So overall time complexity would lead to big of n square because of the nested loops. So this is fine. So what would be the space complexity here? The space complexity would be big of n square as well, because we'll be going with the dp table of size n into n that dominates the memory basically, right? So this will be the space complexity big of n square. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n square and big of n square respectively. Now as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. Now let's start writing the code. I'll just come here. So first we'll be making use of the fast input and output. So I'll just import here input output package. So I'll just go with Java io.start. And also we'll be making use of the different utilities. Let me import the utility package as well. Package as well. So let me go with a class named main. So you can just consider any class. Right. So first let's go with the maximum n from the state. Right. Also let's go with plus one because it has one base. Right. So first let me initialize the state final in equals plus 1 also the mod value now let's go with the problem data and the helpers. Right, so first let's get it let's go with the number of parts. So I'll just go with static in and this is fine. Let's make it the answer that is accumulated, or let's go with the answer that is that we have to accumulate later, right? So using the mod model, right? Small mod in the big. So this one will be static answer. This is fine. And let's go with the input values. This is also one place. Right. So I'll just go with static here. We are considering array a equals new int of let me pass the capital N. So this is fine. Now we also have to go with the count, right? So nothing but count of v is nothing but the number of parts with the value v. So let me go with static here. In equals new int of now also we will be going with the inversion, right? So this is nothing but the modular inverse of k, right? So small mod big mod again. So I'll just go with the static here in. So let me go with the inverse here. This new int of again. Let me pass the int here. This is fine. Now let's go with the dp of iv, meaning probability mod that of the I picks, right? Last value is v and the prefix was strictly increasing. So I'll just go with static here, this one, and so this one will be dp equals new int n. This is also fine. Now the first step is we'll be going with the fast modular exponentiation, nothing but the binary exponentiation, right? Let's write the helper method mod for very quickly. So I'll just go with static here. Now this I'll just name this one mod power, nothing but here this one is binary exponentiation of the modular exponentiation, this one exponentiation. So let me go with the parameters b as well as the e. B is of the type long and e is of the type int. So first thing is let's go with the result accumulator. We need the result accumulator. So I'll just initialize this one to 1. I'll just go with b modulo equals mod. So this is also fine. Next is let me go with the while loop here. This one while exponent is non-zero, right? Nothing but while e greater than 0. Then let me go with a simple if condition here. If e ampersand 1, so this one if it is equivalent to 1, so yeah, I have to consider this one outside the braces, right? So equivalent to 1, then let me go with r equals formula r into v modulo mod. So this is it. So we are just multiplying if bit is set, right? So multiply if bit set, I can just say it on this one, right? So this is fine. Now let's go with the square base, nothing but b equals b into this one b modulo mod. We are going with the b square modulo mod, right? So we are going with the square base. Finally let's shift the exponent right. Let's make use of the right shift operator here. So this is fine. Yep. Now we are left with only one step, meaning we have to return the b to the power of e mod, this one mod value, meaning we have to return r here in this case. So let me come out of this one entirely. We are done with the helper method mod power. Next let's go with the modular inverse of x using the formats theorem, right? So mod will be basically prime if you know the formats theorem. We have made use of this one in this one. We have made use of this one multiple times, right? Yep, basically I'll just give here static and mod power. So let me give here in text, this is fine. So let me return here. Okay, I'm making use of the format theorem, right? So this one will be let's convert this one to the type int. So let me pass here this one mod power. So let's pass x comma. If you remember the formats theorem, we have to go to the mod minus. Right? So this is we are done with this part. So now we have successfully made use of the modular inverse of x using the formats theorem. We have to keep the mod prime, right? So this is fine. We have done that one. Now, so we will be solving the problem within the solve helper method, right? So this is the main solver method. So this reads input, fills the DP and prints the answer. Everything is done within this method itself, right? So let me go with static here. We are done with this, right? So now let's go to we will be adding the count of three times inversion of n. Expect 1 per card of value b to the dp of 1. So I will write it on this side. I use this one. I use this one. So this one will be dp of 1, and also we have to consider a of a of equals. So this will be dp of 1 again. So this one let me copy this dp of a of y. less, inversion of n, right? So we have to do, so this is nothing but dp of 1 and value equals dp of 1 value plus 1 by n, right? This is once per class. So we are done with the for loop thing. So next, let's move on with another iteration. So now we have to iterate the number of picks, right? Picks I from 2 to n. So I'll just go with for I, we have to consider from I equals to 2, right? So I less than or equal to n. So this one will be, so within the for loop, let's compute the prefix sum of dp of I minus 1 and 2. So dp of I minus 1 j becomes sum of k less than or equal to j, then dp of I minus 1 and 2. Right? So again, one more for loop. Yeah. So this one will be j equals to 2. Again, j less than or equal to n. J less. So this is n. So from this loop, so let's go with the dp. So this one will be dp of I minus 1 j equals, so dp of this one again. So this one will be I minus 1 j also less dp of I minus 1 into j minus 1. So we have this one done. This is fine. Now let me come out of this one entirely. So now again, let's go with one more iteration. This time for each possible value j, that is the great transition. Right? So this one I can just write it on this way. So j less than or equal to fine. So we'll be going with the base that is equal to value, the last of j, right? So originally count of j, total, nothing but one of them already given as the last. So we can just go to the count of j. So let's see. One, I just go with the next step would be, we have to go with the probability to step by drawing the other equal value. So this way, so nothing but we can end up only we can make that in this previous example count of j. So this one previous example into count of j minus 1 by remaining equal n minus I plus 1. I told you the last way, the last step. So let's try to articulate the same thing in the form. So this one will be probability equal in as well as L. Now we have to accumulate the building probability. I just assign the answer plus probability plus 1 modulo. So this is fine. Now let's do one thing. Let's go with the probability to extend the simply the value. Meaning procedure. We need the last value that is less than. This is equivalent to the previous sum of the chain number. Right? So we have to multiply by number of spots in value and we have to divide by remaining factors. So accordingly with the output flexibility, right? And then we are done with the logical part. All the things we have done in the past. that